Sorry, Bobby. I forgot to start your recording, so this is kind of where we're at. We're at the very end of the first problem. Hopefully you can follow all this work. Go ahead and pause it and take a look if you want to kind of see where we're going. One thing I want you to look at here, Bobby, is this guy over here. Notice that when we plugged in x is 0, all of the variables basically canceled out, and we have 0 equals 1. That's a false statement, so there would be no y-intercept. Okay, back to you guys. Origin, does it have origin symmetry? Yes, everything works out here. It does have origin symmetry. So let's plug it in Desmos, and let's see what this thing looks like. It should be pretty strange looking. All right, so when you do plug this into Desmos, it does verify it doesn't ever touch the x-axis, it doesn't ever touch the y-axis. You'll notice there's super big asymptotes there. You kind of have to zoom in to see it, but you can see all that information there on your graph. Do you guys have any questions on this one? Okay. Let's try this one. And you guys did copy all these last night, right? So I can just go ahead and go. Okay, well, let's plug in y is 0. If y is 0, it looks like that. How am I going to solve this? What are your thoughts here? There's a couple different ways I can go about this. LCD? Least common denominator? Yes, LCD. So what would your LCD be? X. So if I'm going to do an LCD of x, this last fraction is going to stay the way it is. This is going to need to be multiplied by x over x. So I get 0 equals x squared over x minus 1 over x. This is okay because x over x is basically like multiplying by 1. If I put those together, now it looks like this. Now you're probably saying, okay, yep, x can't be 0, but I'm not concerned with my domain here. I'm concerned with the x-intercept. So if I want this to be 0, what do I know about that fraction? How do I make a fraction be equal to 0? The top has to be 0. So I need the numerator to be equal to 0. And what will make that numerator be equal to 0? Or, so how many times does this thing cross the x-axis? Twice, at +1 and at -1. Same idea for the y-intercept. I'm going to make my x be 0. And what are you going to tell me? Can't do it. So what do I know about my y-intercept? There is none. I can't have that 0 in the denominator. Let's go for x-axis symmetry now. If I take my y and make it negative, is there any way for me to simplify this to recreate the original problem? The answer is no. You might think, okay, maybe I can divide this negative off of this y, but if I do that, I have to do that to the other side, and then it's even more messed up. Okay, so this has no x-axis symmetry. Let's try y-axis symmetry. Okay, what do you guys think here? I would say no as well. Let's make sure we can calculate this algebraically here. See this minus minus here? What is that going to turn into? So really, I have this. So it's super close because I really could take out a negative here on this side. Does everybody see how I could take a negative out of both of those and it would make this over here? But if I take a negative out of those, I got to take a negative out of this y too. So hopefully we can make the origin one work. Looks something like that. So I'm going to go ahead and make those minus minuses pluses at the end. How is that for everybody? Yes? How can I recreate the original problem from this? Divide everything by a negative. Is that legal? As long as you do everything, it's okay. If I divide this by -1, divide both of those by -1, I get back to my original equation. So this thing does have origin symmetry. All right, go ahead and type that in. Let's see what it looks like. Okay, so this is very easy to see the origin symmetry because it literally is just a mirror from one diagonal to another. Any questions here? All right. Everybody's favorite, the step function. Okay, this is our step function. This one takes a little bit of thinking on your part because this is not a typical function here. If I make the y be 0, it looks something like that. So for what values of x will the function be 0? 0. Is that the only value that will make it 0? What does this mean? Read this to me. What does this notation mean? No, the greatest integer less than or equal to x. So what other kinds of numbers could I put in there? So the greatest integer less than or equal to it would be 0. Say it again. If I put a 1 in there, what is the greatest integer less than or equal to 1? It's 1. Anything between 0 and 1. Can I include 1? No. Think about it, guys. If I put a 0.5 in there, what's the greatest integer less than or equal to 0.5? 0. Greatest integer less than or equal to 0.9? 0. Anything between 0 and 1, because folks, you're going to have a step there. So that whole line is going to be on 0, isn't it? So all of those are x-intercepts. Y-intercept means I need to make the x be 0. So what's the greatest integer less than or equal to 0? So my y-intercept is just 0, 0. Let's talk about symmetry. Because I can plug in lots of values here that'll bring my answer back down to 0. 0.1, 0.2, 0.57, 0.77. All of those will come back down to 0. But here, I'm putting a 0 in there. The only answer that spits out is 0. Good question. Now, when you talk about symmetry, I hope you can just think about what this looks like. Y'all know what your steps look like, right? Do you think that's going to have x-axis symmetry? Do you think it's going to have y-axis symmetry? Do you think it's going to have vertical symmetry? Or I'm sorry, origin symmetry. Origin means flipping over the origin, right? Let's see if that works. If I do origin symmetry, what's that going to look like? That would look something like that. Can I divide out the negative? this bracket means I have to do something to it before it comes out, right? It's kind of like an absolute value where you have to do the absolute value before it comes out. I can't actually divide both those negatives out because it can only come out after we do what's inside of there. Does that make sense? So this thing will not have origin symmetry. Honestly, you might think that it would, but when you flip it over the origin, the open dots and the closed dots won't match up. They'll be like on the wrong ends. Okay. Let's do a square root function. If I want to make this thing have a y-intercept or an x-intercept, the y has to be 0. So you probably can just look at it and tell me what the x would have to be. Or, okay, so I have plus or minus 3, 0. If you wanted to, you could square both sides, you could subtract the 9, you could divide by the negative, and then take the square root, and you still would get plus or minus 0. If I'm going to find my y-intercept, it looks like that. So what is this going to give me? Okay. Got my intercepts. Let's go to x-axis symmetry. And again, you don't need to show all this work if you don't think that you need to. It's just me kind of proving it to you here. Does this work out? Can I turn this into this? No. Say it again. Because I'm not taking the square root of a variable. I'm taking the square root of a number that I know. It's just 9. If there was a plus or minus out front here, then it would be plus or minus. Okay, I know it's just 9. And we are mathematically trained that if it's there, we just take the positive version. If there was a plus or minus sign out front, then it would be plus or minus. Okay. Where am I at here? Y-axis symmetry. What do you guys think? Good to go on that one? Yes? So what kind of function is this if it has y-axis symmetry? Is it even or odd? Which one is it? One says even, one says odd. Okay, even. Origin symmetry. Can you guys just tell me what origin symmetry is going to be? It's going to be a no, right? There's no way I'll be able to make that work. Okay, go ahead and put it in. Oh, what's it look like? Hopefully, you could kind of guess what it looks like. It's a square root function that's a square underneath it. So what's it going to look like? Should be a semicircle. Remember, a square root just has half of that. Okay, once I square what's underneath there, then it becomes the full semicircle. Any questions there? Okay. I believe this is my second to last one. Double square root this time. I got a square root over the x and a square root over the y. If I make the y be 0, what would x have to be for the intercept? Everybody all right with that? Yes? 1, 0. If I make the x be 0, what does the y have to be? Okay. Oh, I'm pretty sure we can just think about all of these. Will x-axis symmetry work if I make the y negative? No. Will y-axis symmetry work if I make the x negative? Will the origin symmetry work if I make them both negative? No, because they're both going to be negative under square root. So this thing has no symmetry. What's it look like? much in than it does to... Yep, just a little itty bitty curve. Can anybody tell me why that little itty bitty curve is only in the first quadrant? I can't have a negative x or a negative y at all. And the only place where both x and y are positive is in the first quadrant. Okay. The last one here for us. We got a double absolute value. X-intercept. If the y is 0, it looks like that. Absolute value of 0 is just 0. So, what would x be to make that be 0? Just 0. Okay. For my y-intercept, if I make the x be 0, pretty much looks like the same thing. What would y have to be? 0. So we're only going through the origin for my intercepts. All right, let's look at some symmetry here. What do you think? For sure, right? Because that absolute value takes the negative out. What do you think about that one? Still a yes, because that would be a negative 3x in there, right? Basically, the absolute value takes care of that. What do you guys think for origin? Yep. What's it look like? Should be an x. But it's not an x that cuts straight through the quadrants, right? Isn't it a little skinnier? It's a little skinnier because of that 3x out front. Questions for me today? Nobody? Okay, so this is your homework that you have the rest of the period to work on. Monday, we will do just a few more examples, and then your quiz will be on Tuesday. Any questions for me? All right.